Greetings. I've come to share the beauty of numbers, a language that transcends time.
Hello! Today we're going to learn about some important symbols used in mathematics. We'll explain each one in Sesotho, Sepedi, and IsiZulu. By the end of this video, you will be able to recognize and understand the basic meaning of these symbols. Let's start with the subtraction operator for sets. In English, we use a backslash. In Sesotho, we say NTSHA ka mokotlang. In Sepedi, it's NTSHA ka mokitlaneng. And in IsiZulu, we say Khipa esikhwameni. This symbol means to take away or remove elements from a set. Imagine you have a bag of fruit. Let's say our first set, set A, has an apple, a banana, and an orange. And our second set, set B, has a banana and a grape. If we want to find A minus B, we take everything in set A and remove anything that is also in set B. The banana is in both sets, so we remove it. What's left in set A? The apple and the orange. So A minus B is the set containing the apple and the orange. So, TSHA kamokotlang, in TSHA kamokotlaning, or kipa esikwameni, means to remove elements from a set. Next, we have the existential quantifier. It looks like a backward E. In Sesotho, we say hu nale or nale. In Sepedi, it's in nale or gona. And in IsiZulu, we say kukona. This symbol means there exists, or there is at least one, kensan. It tells us that a certain condition is true for at least one thing in a group. Let's look at a group of shapes. Here we have a circle, a square, and a triangle. We could write a statement like this. Honali, a shape that is a circle. This is true because we can see a circle in our group. Or gona, a shape that is a square. This is also true because there is a square. But if we said kukona, a shape that is a star, that would be false because there are no stars in our group. So honale, nale, gona, or kukona means that at least one thing exists that meets a certain description. Now for the universal quantifier. It looks like an upside-down A. In Sesotho we say kahokle, in Sepedi it's kamoka, and in IsiZulu we say zonke. This symbol means for all, or hako, for every. It tells us that a condition is true for every single thing in a group. Let's use our shapes again. Here we have three circles. We could write kahole shape in this group is a circle. This is true because every shape is a circle. Now let's look at a different group. If we said kamoka shape in this group is a circle, that would be false. The square and the triangle are not circles. So kahohlite kamoka, or zonke, means that a statement is true for every single member of a set. Our next symbol is the Greek letter epsilon. In Sesotho we say nomoro enyane. In Sepedi it's nomoro enyane. And in IsiZulu we say inombolo enkane. Epsilon represents a very, very small number. It's a number that is close to zero, but not zero itself. Think of it as a tiny, tiny distance. Imagine you are standing on a number line at the number 5. You are at the point 5. If I ask you to take a step of size epsilon, you would move just a tiny bit away from 5. You would be at 5 plus epsilon, or 5 minus epsilon. The important thing is that epsilon can be made as small as we want. It's a placeholder for a number that is almost zero. So namoro enyane, or inambolo enkene, represents a very small positive number. Now for two symbols that help us explain our reasoning. The first is because. In Sesotho we say hobane. In Sepedi it's gobane. And in IsiZulu we say goba. This symbol is used to show the reason for a statement. It's like saying since or on account of. Let's look at an example. We can say, the triangle has 3 sides. Hobane, it is a triangle. The reason it has 3 sides is because it is a triangle. Or we can say, the apple is a fruit. Goban, it grows on a tree. The reason it's a fruit is because it grows on a tree. So, hobane, gobane, or goba is used to introduce the reason for a statement. The second symbol for reasoning is therefore. In Sesotho, we say kaho, kalabakalahore. In Sepedi, it's ka-f-a-o, or kalabaka lagore. And in IsiZulu, we say nakoke. This symbol is used to show the conclusion that follows from a statement. It's like saying, as a result, or atilu, it follows that. Let's combine it with our because symbol. We can say, hobane, the sun is shining. Kahu kalabakalahore, it is daytime. The conclusion that it's daytime follows from the fact that the sun is shining. Or, gobani, the square, has 4 equal sides. Ka, F-A-O, it is a rhombus. The conclusion that it's a rhombus follows from the fact that it has 4 equal sides. So, kahu kalabakalahore, ka, F-A-O, ka labakalagore, or ngakoke, is used to introduce a conclusion. Next up is the integral sign. It looks like a tall, skinny S. In Sesotho, we say palayole. In Sepedi, it's palamoka. And in IsiZulu, we say isamba. This symbol is used to calculate the total amount of something that is changing continuously. A common use is to find the area under a curve. Imagine a curved line on a graph. We want to find the area between this curve and the bottom line, the x-axis. The integral sign tells us to add up an infinite number of tiny rectangles that fit under the curve. Each rectangle has a height, which is the value of the function f of x, and a very small width, which we call dx. The integral adds all these tiny areas together to give us the total area. So, paloyoli, palomoka, or isamba, means to find the total sum of something that is changing continuously, like the area under a curve. It looks like 2 wavy lines. In Sesotho, we say kaba or kabang. In Sepedi, it's batametsego or nyakile. And in IsiZulu, we say chishi or isondelene. This symbol means approximately equal to wu. We use it when a number is very close to another number, but not exactly the same. For example, the number pi is a very long decimal. Pi is approximately 3.14. We use the approximation sign because 3.14 is very close to pi, but it's not the exact value. Let's say you have a bag of 100 apples, but you're not sure if there are exactly 100. You could say, the number of apples is she 100. It's close to 100, but maybe it's 99 or 101. So kaba, kabang, batametsego nyakile, she, or sondelene means approximately equal to. Now for the modulo operator, often written as mod. In Sesotho, we say setseng. In Sepedi, it's lesalela or lesaledi. And in IsiZulu, we say insalela. Modulo finds the remainder when one number is divided by another. It's like asking, what's left over? Let's say we have 7 apples, and we want to divide them into groups of 3. We can make 2 full groups of 3, which uses 6 apples. We have 1 apple left over, so 7 mod 3 is 1. Think of a clock. If it's 10 o'clock and you add 5 hours, what time is it? 10 plus 5 is 15. On a 12-hour clock, 15 is the same as 3, so 15 mod 12 is 3. The remainder after dividing by 12 is 3. So setseng, lesalela, lesalera, or insalela means to find the remainder after division. Next is the notation for a function, f of x. In Sesotho, we say disebediswa, tiese kamano. In Sepedi, it's tirisoyago ichama. And in IsiZulu, we say inguko enchikile. A function is like a machine. You put something in, and it gives you something out. The x is the input, and f of x is the output. The letter f is just the name of the function. Let's say our function machine is double the number. We can write this as f of x equals 2 times x. If we put in the number 3, the machine doubles it and gives us 6. So f of 3 equals 6. If we put in the number 5, the machine doubles it and gives us 10, so f of 5 equals 10. So, disabadizwa, tsa kamano, terasoya go it shama, or inguko and chikile, is a rule that takes an input and gives exactly one output. Finally, let's look at two symbols for combining sets. The first is intersection. In Sesotho, we say mateanong. In Sepedi, it's magahlanong. And in IsiZulu, we say impambano. Intersection finds the elements that are common to two or more sets. It's like finding what they have in common. Let's use our fruit again. Set A has an apple, a banana, and an orange. Set B has a banana and a grape. The intersection of A and B, written as A intersect B, is a set of fruits that are in both set A and set B. The only fruit they both have is the banana. So the intersection is the set containing just the banana. So mateanong, magahlanong, or impambano means to find the elements that are shared between sets. The second symbol for combining sets is union. In Sesotho we say kopano. In Sepedi it's kopano. And in IsiZulu we say I-Q-O kongjube. Union combines all the elements from two or more sets into one new set. It's like putting everything together. Let's use our fruit sets one last time. Set A has an apple, a banana, and an orange. Set B has a banana and a grape. The union of A and B, written as A union B, is the set of all fruits that are in set A or in set B or in both. We list every unique fruit from both sets. We have an apple, a banana, an orange, and a grape. We only list the banana once. So the union is the set containing the apple, banana, orange, and grape. So kopano, or IQO chongchube, means to combine all the elements from different sets into one. Great job! Today, we've learned about several important mathematical symbols and their meanings in Sesotho, Sepedi, and IsiZulu. We covered symbols for set operations like subtraction, intersection, and union. We also learned about quantifiers like there exists and for all, and symbols for reasoning like because and therefore. Finally, we looked at symbols for approximation, remainders, functions, and advanced concepts like integrals and gradients. Understanding these symbols is a key step in learning mathematics. Keep practicing, and you'll become more familiar with them. Thank you for watching.